I smell you hobbits as you come back to Pocket Ronnie.
Okay, I'm going to use this to show you how we get to a specific trig identity. Okay, with trig functions, we use sine, cosine, and tangent for right triangles. So here we have a right triangle. So when you have a right triangle like this, what else do you think of for a right triangle? Hopefully you're saying Pythagorean Theorem. So Pythagorean Theorem, math U See would do leg squared plus leg squared equals hypotenuse squared. Other textbooks, you see it as a squared plus b squared equals c squared. A and b are the legs of the triangle and c is the hypotenuse. Okay, so let's just say we wanted the right side to be 1. How do we get the right side to be 1? We divide c squared by itself, because c squared divided by c squared is 1. Well, in the world of algebra, whatever we do to one thing, we have to do to everything to make the equation balanced. So we divide everything by c squared. So this now becomes 1. So instead of just writing this a squared over c squared, I'm going to write it a over c squared, because that's the same thing. Because that means a over c times a over c. That would be a squared over c squared. Okay? So now I'm going to write this as b over c, the whole thing squared, and then this became 1. Well, looking at your triangle, if you're standing here at theta, if you're the little man standing at theta, and you were doing a over c, standing here, a is the opposite of you, c is the hypotenuse. Which trig function is opposite over hypotenuse? Sine. So a over c would be sine theta, and then with squared, we put our square, when we do trig function squared, the exponent is in between the trig function word and the angle. And then b over c, if you're standing at theta, b is the side adjacent to you, c is the hypotenuse. Adjacent over hypotenuse is cosine squared theta equals 1. This is Pythagorean Theorem in trig notation. So this is Pythagorean Theorem in trig notation. We use this for trig proofs. So if you can just commit to memory that sine squared plus cosine squared equals 1, you can use it in trig proofs. So you can also use different forms of this. What if we subtracted sine squared to the other side? Then we would have cosine squared theta is equal to 1 minus sine squared theta. What if we wanted to subtract cosine to the other side? Then that means sine squared theta is equal to 1 minus cosine squared theta. We can also put negatives in here. What if we wanted to make this a negative? We've multiplied it by negative 1. Okay, so I'm just going to rewrite that. That if we had cosine squared theta equals 1 minus sine squared theta. What if we had a negative? We multiplied that by negative 1, which means we have to multiply everything by negative 1, which means now we would have negative cosine squared theta is equal to a negative 1. Negative 1 times a negative is a positive. But instead of seeing it like this, you will usually see it like this. Sine squared theta minus 1. The same is true if we took the sine squared. If we have negative sine squared, that would end up being cosine squared theta minus 1. These things that I have circled will be things that you can use in trig proofs to help you prove trig functions. If you see a sine squared plus cosine squared, you can replace it with 1. If you see a 1 minus sine squared, you can replace it with a cosine squared. And you can use any of these identities like that to help you with trig proofs.